Hi, good day again. My name is William T. Dongo. I'll be presenting the continuation of the lecture. The one we're gonna be talking about is about lesson number 4. Okay, the climate control and refrigeration technology, the fundamentals of air conditioning and refrigeration. And then we'll be now talking about lesson number 3. The title is Air Conditioning, Cycle, Components, and Mechanical Diagram. Got it? Okay, we'll be talking about the theory of operation, the purpose, the compressor, the condenser, the metering device, evaporator, that's the cooling coil, and then we gotta talk about the refrigeration lines. We gotta be talking about the discharge line, the liquid line, the suction line. And then we gotta go to the components, the compressor, the condenser, okay? And then the metering device, the evaporator. And then we gotta go to with the accessories. You got liquid receiver, you got the suction accumulator, you got oil separator, liquid line filter, suction line filter, and the moisture indicator. Okay, that's theory of operation. The purpose. The purpose of this refrigeration is to remove unwanted heat from one place and discharge it to another. To accomplish this, the refrigeration is pumped through the closed system. Just like the diagram I had here, that's a refrigeration cycle. This is an enclosed system. Okay? If system was not closed, it will lose the refrigeration and dissipate it into the air. This way the refrigerant is used over and over again. Heat is not destroyed. It is removed from the conditioned space and released elsewhere. And then the first one will be, we have here is this, the compressor. This one right here. Compressor is a low pressure, low temperature vapor is drawn into the compressor. Low pressure, low temperature vapor. By the suction line. The suction line, and then compressor compresses this vapor into high temperature. It compresses to the high temperature, high pressure vapor. We call it HPHL vapor. High pressure, high temperature vapor. And then discharge the vapor to the condenser. By discharge line, we call it a high side. And then the compressor, vapor entering the condenser is a higher temperature than the ambient air temperature passing over it. Heat is transferred from refrigerant vapor to the controlled air, cooler air. When heat is removed from vapor, it changes the state of the vapor to liquid. Vapor is condensed back into a liquid. Liquid is then at high pressure, high temperature, which is HPHT liquid. Liquid then travels from condenser to the liquid receiver. Okay, and then to the metering device, the one right there, by the liquid line. And then the metering device. Metering device, I got one right here, which is what we call the expansion valve. It's a high pressure liquid that enters the metering device will have drop in pressure. This is due to the restriction design into the metering device. By dropping pressure, the refrigerant boiling point also drops. Metering valve is designated to control the exact amount of low pressure liquid to enter the evaporator. Okay, and then we gotta get the evaporator. It's the cooling coil, which is this one right here. The refrigerant evaporates, changes state as it goes through the cooling coil. As it goes to the cooling coil, from the bottom part it goes up. As it goes to the tube, it starts absorbing heat. Okay. This removes heat from the air being conditioned. Heat will travel from warmer air to the coil, okay, to the coils. Coils cool by the refrigerant liquid. This causes the refrigerant to boil over or evaporate. Changes refrigerant to a low pressure, low temperature vapor, in which we call the LPLT. It will go up to the evaporator. When it's in the evaporator, it enters. As it goes through, it pick up heat inside the evaporator box, and then it turns to liquid and go out to the discharge of the evaporator. Okay, changes refrigerant to low pressure, low temperature vapor, which is LPLT vapor. LPLT vapor is moved back to the compressor. This is the compressor is right here. Process start all over again. Okay, first the liquid, the gas goes to the compressor out. It discharges it and goes to the condenser, and then the condenser will condense the gas and turn it into a liquid and goes to the receiver. And then when it goes to the receiver, it go up to the line right here, the liquid line, and then it goes to the metering device, which is one right here. They call it usually is a thermal static expansion valve. As it goes through there, it pick up heat, and then from liquid it start changing state into gases, and then go out and go back to the compressor. Okay, these two right here, we got a liquid low pressure side and the high pressure side. The reason we need the high pressure side, so that we can condense the refrigerant to liquid again when it goes to the high side, in which you take the heat, what we call latent heat. You take the heat, but you okay, so you got a low side and a high side. Okay, refrigerant line. We got a discharge line, refrigerant line, discharge line. Location between the compressor and the condenser. This is the liquid line right here. Okay, located between the compressor and the condenser. Contains high pressure, high temperature vapor, HT, HT vapor. And then you have a liquid line. Liquid line located between condenser and the metering device, because once it goes to the receiver, it will go in a liquid and then it will be pumped out and go back to all the way to the metering device. Contain high pressure, high temperature liquid, HPHT liquid. And then you have the suction line. Location between the evaporator and the compressor. This is the suction line. Condenses low pressure, low temperature vapor, LPLT vapor. Okay? And then we have the compressor. The compressor is right here. The purpose of the compressor is to circulate refrigerant through the system. Receive or remove the refrigerant vapor from the evaporator, so the desired pressure and temperature can be maintained. Increase the pressure of the refrigerant vapor through the compressor, through compression. As pressure rises due to temperature, this heat is established, a delta T, between the refrigerant vapor temperature inside of the condenser and the cooling medium at the condenser, i.e. air or water. In the actual condenser you might have a pin here. You will have a pin on the coil. And then you blow air through the condenser and then it will discharge the heat. And then you got three types of compressor. You got reciprocating type, you got rotary type, and the scroll. Reciprocating type uses in majority of domestic, commercial, and industrial condensing unit application. Three classification. You got the hermetic, not field service, and then this type of compressor is sealed. And then you have a semi-hermetic, field serviceable. And then you got a open, that is field serviceable. And then you have you have a piston type compressor, and then you have rotary crank shaft with connecting rod attached to the piston, moves piston up and down inside the cylinder. It's just like a car, reciprocating. You got a car, piston type car. As piston moves downward, low pressure, low temperature vapor is pulled from the suction line into the cylinder through the suction valve, and then discharge valve is closed. Reciprocating type pump, as a piston moves upward, HPHT vapor is compressed and pushed out through the discharge valve. Suction valve then closed. Arrangement of the cylinder may be horizontal or vertical. May also be in a straight line or arranged to form a V or W shape. And then we got the next one. We got the rotary type pump. Rotary type pump operates through application of rotary or circular motion. Usually can pump a deeper vacuum than other types. Two primary types. You got the rolling piston type as a stationary blade. Rotating vanes. Okay? Rotating vanes. The other type is rotating vanes. Suction and discharge ports are located within the cylinder walls. LPG is drawn, that's low pressure gas, is drawn into the cylinder through the suction port. Vapor is compressed and discharged through the discharge port. When the compressor is idle, high pressure, high temperature vapor may leak back into the evaporator. A check valve on the suction line will prevent this from happening. And then we have the third one. You got the scroll type. The scroll type is designed in which it is simple, efficient, and requires fewer moving parts. Two identical scroll are mated together, forming concentric spiral shapes. One scroll remains stationary while the other is allowed to orbit. Orbiting scroll draws low pressure gas into the outer crescent-shaped gas pocket created by the two scrolls. The centrifugal action of the orbiting scroll seals off the plank of the scrolls. As orbiting motion continues, the gas is forced toward the central of the scroll. Gas pockets become smaller and smaller and further compressed. When compression gas reaches the center, it is discharged vertically into the chamber and discharge port located in the top of the compressor. Two-stage compressor. What is two-stage compressor? Two-stage compressor may be accomplished in two ways. Two compressor with one discharge into the suction of the other. One compressor with multiple cylinders unloading. Unloaders. Repeat myself on that. One compressor with multiple cylinder unloader. And then how we lubricate the compressor. Lubrication. An adequate amount of oil must be maintained in the system. Two methods used for lubrication. One method is a splash method and the other one is a pressure method. The splash method is good for a slow speed compressor. Force method use passageways to force oil to the appropriate places. Compressor over 3 horsepower need more lubrication. And then you gotta have a oil pump inside the compressor. And then we got the compressor construction. Construction of the compressor, we got the open type. Use a motor, a drive belt, and a flywheel attached to the crankshaft. The shaft must exit the compressor. Uses a crankshaft seal to prevent loss of refrigerant and oil. The semi-hermetic compressor. Electric motor mounted directly on the crankcase. And then motor and compressor are sealed within a common housing. This one you use it, you see it, semi-hermetic. Removable plates and covers, access for easy repair. And then we got the hermetic compressor. That's the seal type. Motor and compressor mounted on the common shaft. The body is in the form of metal shell, hermetically sealed by welding. No field repairs can be made. Okay? That's the compressor. Now we're going to talk about the condenser. The condenser is right here. The purpose of condenser. Condenser remove heats from the compressed refrigerant vapor. Remove heat from compressed refrigerant vapor, changing it to a liquid form. You got, what are the type? You got the air-cooled and the water-cooled. Air-cooled type, most popular, used on small commercial and domestic refrigeration and air conditioning. Construction of the tube and external pins design. Okay, dissipated heat to the ambient air. Heat transfer is accomplished by one or two ways. Natural convection, found on small domestic unit. Depends on gravity air circulation. Warm air rises and is replaced by cooled air. And then you got the forced convection. Forced convection is a forcing large quantity of air through a compact condenser assembly. Usually about 1000 CFM per ton of refrigeration. And then you have the water cooled, just like a cooling tower. Water cooled used when adequate low cost condensing water is available. Lower condensing pressure and better control of discharge pressure is possible. Water is usually much colder than ambient air temperature. Cooling towers are often used. When I was in the Navy, we used the seawater, and then we got so much abundance of the seawater. When we use it for our refrigeration unit, you know, when we cool we got a condenser there. And then condenser capacity. Heat transfer of a condenser depends on several factors. Surface area of condenser, temperature difference between the cooling medium and the refrigeration vapor, delta T. The velocity of refrigerant gas in the condenser tubes, vapor amount added to the condenser must equal vapor condenser being condensed to liquid. Rate of flow of cooling medium over through the condenser, water or forced air. Material of which condenser is made. Okay, heat transfer differs with different material. Just like I discussed on the last chapter. Cleanliness of heat transfer surface. Okay, make sure you maintain the cleanliness of the heating surface, because that's where if it's dirty and then you lose a lot of heat transfer to that. Dirty or clogged condenser is inefficient. Condensing temperature. Temperature at which the refrigerant vapor becomes liquid. Okay, and then we talk about now the metering device right here. The metering device. I'm gonna do some work over here that I have missed. We need to make a connection here. Right here. Okay, metering device. Metering device controls the flow of liquid refrigerant to the evaporator. Provide pressure drops, which also drops temperature of refrigerant, thus lower the boiling point. Operated by different forces. The temperature, the pressure, combination of temperature and pressure. When it comes to the big refrigeration system, then you use a pressure type sensing elements. And then for the refrigerator, you got the temperature one. Just like this TXB expansion valve, I didn't put the sensing element. There's supposed to be a sensing element that's hooked up to the evaporator on the almost near to the exit end. They call it a thermostat. Type most commonly used today, automatic expansion valve, okay, known as constant pressure valve. Hold evaporator pressure at a constant level regardless of the load. Allow refrigeration to flow in the allow refrigerant to flow in the evaporator during the on cycle only. Pressure in evaporator must be reduced before valve can open. Works on the spring and atmospheric pressure versus evaporator pressure. Okay? Use on system with constant load. And then continue on metering device. Another type is a thermostatic expansion valve, TXV. Most commonly used in refrigeration system, allows refrigerant to flow in the evaporator during the on cycle only. Workers on valve pressure versus spring and evaporator pressure. Automatically adjust to compensate for variable evaporator loads. Maintain constant superheat. Okay? It maintains constant superheat. And then we have a capillary tube control. Tube with a very small inside diameter. Inside diameter and length of tube controls the amount of refrigerant flow in the evaporator. Maintain a constant pressure difference. between the high and low sides during the on cycles. Longer capillary tube, the greater the pressure drops. The smaller the inside diameter, the greater the pressure drop. Use on constant load system. During the off cycle, the system pressure is balanced. Okay, that means at off cycle, that means all the pressure in here that you meets your temperature, that the unit will shut down. Okay, and then once the temperature goes up again, the TXB will sense that, and then the unit will come on again. And then the evaporator, which we have right here. Evaporator, the purpose is to absorb heat into the refrigeration system. Place inside area to be conditioned. This one right here, we got a condenser. Let's say this is a refrigerator. Then the evaporator. Okay. Basic type. Dry or direct expansion type, DX. Formed by continuous piece of tubing. Refrigerant is metered at one end. Suction line connected to the other end. No separation between the liquid refrigerant and the vapor refrigerant anywhere in the evaporator. Refrigerant flows through the tubing while it evaporates and absorbs heat. Just like you see in here, I put a blue one and it becomes green. So what happens as it goes in here, it starts absorbing heat, and then it goes up, and then suddenly it will turn to green little by little, and then this will be a vapor, low pressure vapor, low suction, and then it will come to here. The compressor pump it to high pressure, and then goes in the condenser, and then the heat will be removed from the condenser. Once the heat is removed, and then it will turn to liquid and go back to the receiver. Now, the next one we'll be talking about is the evaporator styles. We got blower coil or forced convection. Most common. Liquid refrigerant evaporates inside the pin tube, just like you see on your air conditioning. Absorb heat from the air that is blown across or through the coil by a fan. And then you got bare coil, uses no fin, may use a fan. Okay. And then you got gravity coil. Gravity coil uses natural connection airflow. And then the plate or shell type, found in freezer application. Then the next one we're gonna talk about will be the accessories. We will have the liquid receiver, which the one I put in here, liquid storage tank for refrigerant which is not in circulation, located in the liquid line. So this is because this one gotta be liquid once it passed to the condenser. And then suction accumulator. Suction accumulator helps prevent liquid refrigerant from reaching the compressor, causing damage to compressor if located in the suction line. And then we have an oil separator. Oil separator separates the oil from the refrigerant, located in the discharge line. I don't have it here, but that's extra accessories you can put to the system if it needs to. And then you got liquid line filter dryer, designed to perform the following: remove moisture in refrigerant, filter refrigerant, and remove some acid. And then this one is located in the liquid line. And then the next one we're gonna have is the suction line filter. Suction line filter protect compressor by collecting any foreign matters on its way to the compressor. Should be installed in a vertical position if possible. Should be installed as close to the compressor as possible. And then you got a moisture indicator. Moisture indicator is good accessories because it aids in servicing the unit. Located in the liquid line. Can sometimes be used to diagnose problems. Visual aid to determine pressure on moisture in the system. Moisture indicator, you got a glass in there, you can look at it. Once the refrigerant passes through it, you can see some bubbles if there's air in there. Now, that's the end of the lecture, but to summarize it all, we got the refrigeration cycle that I made a diagram here. The four parts of the main parts of the refrigeration system is the compressor, the condenser, the expansion valve, which is the metering valve, and then you got the evaporator. And then this system, we got two sides. You got the low pressure side and the high pressure side. The high pressure side is on the compressor side. It starts from the discharge of the compressor to the condenser, to the liquid receiver, and then to the other side of the TXB valve. Once it exits the TXB valve, the pressure will go down, and then it goes to the evaporator. As it goes to the evaporator, it start absorbing heat. As it absorbs heat, the liquid refrigerant will start turning to vapor. And then when it turns into vapor into the evaporator, it will exit, and then it goes back to the compressor. Once it's in the compressor, you gotta make this to the high pressure, so that when it reaches the condenser, it will turn to liquid again. That means that once the way it works out is just you remove the heat you make it into vapor. You put it high pressure, and you put the heat will be, then the latent heat will be removed in the condenser. Okay, that's the lecture that I have, and I thank you very much. There finished the lesson 3 on it.